Okay, welcome everyone to another Requirement Working Group Exchange Cafe. This is a continuing session on system security challenges that Beth Wilson is leading. Last month, she provided us a summary of system security challenges when it comes to defining needs and verifying the system meets the system security requirements, validating it meets the needs. After that, we had a really good discussion, and that recording was put on the RWG YouTube site. And this is also put on both the Yammer pages for Requirement Working Group as well as the System Security Engineering Working Group. During this meeting, we're going to continue that discussion. And one of the things that Beth is going to be working on is kicking off a project to develop a system security engineering guide that tailors what's in the Requirement Working Group products to fit in with the system security needs and requirements. I went through the bio last time, and so I won't go into detail on the bio this time. For the Requirement Working Group, I'm going to point out next month, we're going to have a presentation by Henrik Matfork on configuration management across the digital thread. This is a follow-on to a presentation he gave before IW last year about the digital thread. And then in January, we are starting to plan for IW. I know we're going to have several joint collaboration sessions with other working groups. Tammy is starting that process. Each working group is going to have their own standalone meeting, talking about what they did last year, their current status, review their charter, and talk about what the plans are for 2023. So I'm going to stop sharing, and I'll turn the meeting over to Beth.
This is a kickoff to this project, and what we're trying to do is put together a guide that speaks to the systems security engineering perspective on the needs and requirements manual, the guide to writing requirements, the guide to needs and requirements, the guide to verification and validation. The idea being that these requirements working group products go into detail about what activities should take place to effectively capture the needs, write effective requirements, do the verification against the requirements, and be able to validate against the needs. But there's also other steps in the lifecycle model for the requirements. And there are two different projects that I'm working on. One is doing a similar thing for a system of systems. And the reason I'm trying to do these at the same time is because my thought is if we can come up with a format for this domain-specific guide that works for two working groups that have unique perspectives on needs and requirements, then that might be a good model for other working groups to do those kind of guides. All right, so just to summarize in one place, so these are the definitions we described at the meeting last month. And as a reminder, we're looking at both the cybersecurity and the cyber resiliency, the idea that we want to be able to function under nominal and adverse conditions. We want to protect the system from a threat, some of them being cyber, other threats are not necessarily cyber, and to be able to react to a threat to make sure that we have mission success if the adversary is able to get in. We talked about cyber risk assessment as the way we define what the system security capabilities need to be. So we need to identify what are those critical assets. We identify critical mission threats, and then we conduct the cyber risk assessment where we have these scenarios that tell a story about a potential threat that exploits a vulnerability in the system to impact a critical asset in the system that would lead to a mission loss. So the perspective is on the mission scenarios and the criticality analysis against the mission, the threat against the mission, and the vulnerability to that threat. I use the word misuse cases, trying to encourage my students to think about the use case scenarios for the system. These are the things you want the system to do, and which of those use cases are critical to your system that you want to make sure that you don't lose that capability if you are attacked. And so this idea of this misuse case, a companion misuse case, is easier to think about when you're thinking about the use cases, but these represent these loss scenarios. And then I talked about some anti-patterns. These are all the things that we've seen and hang our heads at when we say the need part is we want to have a secure system. But then we go through these anti-patterns, and when we get to validation, we say, oops, the system's not secure after all. And so one of the anti-patterns was, we'll worry about it later. We'll just send it to a cyber range, and the white hats will give us a punch list of things we need to harden. The second anti-pattern was the security controls. This is where we just look at the NIST 853 controls, and verification is a checklist of all those controls. We basically open up the controls closet, pull everything out, and we say we need everything in order to get our security certification. And the system is not secure after all when we get to validation. There's also the aspect of the anti-pattern of security review after design. So we finally win a seat on the architecture review team, and we identify our loss scenarios, but then they say, well, it's too late to change anything. So allowing the security experts to review the architecture after it's complete and after the design team is really sentimental about it is not helpful, because it's difficult to change. We also have where system security is considered to be a non-functional requirement. So the requirements team will write the system shall do some function securely. They just add the word securely to the back of it. And then what ends up happening is then the architecture will add a firewall. Maybe we'll require some passwords. We say we're all set. We're checking for basic security measures. We're not focusing on those loss scenarios. And then another anti-pattern was the one security expert. We had the security guy look at it. We're all set. Don't do yourselves any favors when you have the information assurance expert that has IT credentials and ask them to write anti-tamper requirements, or to have a software assurance expert review a supply chain statement of work. So these were the anti-patterns. And at the end of talking about these anti-patterns, I presented what we want. And from my perspective, what we're looking for. And you going back to the requirements working group, verification and validation in context, what we want is that the needs are focused on which mission threads are critical, because these mission threads are the ones that must survive an attack by an adversary. When we talk about requirements development, we want to develop misuse cases. We want those loss scenarios to drive the analysis. We want to develop security requirements that are system capabilities to prevent those losses. And we want to treat security as a functional requirement. And I added architecture here because in architecture development, we review those mission threads as architecture products are being developed. That identifies security gaps, which can lead to additional security requirements. And then in verification, we want to confirm that the mission can be successful with the misuse cases in the loss scenarios. And doing validation in the cyber range is a good thing. It's just not a good thing if it's the only thing. I wanted to point out this, the special publications 800-160 has 2 volumes. The first one is called Engineering Trustworthy Secure Systems, and it has a detailed mapping of the needs, requirements, verification, validation activities that relate to system security engineering. So in section 3.4, for example, there's a section on business or mission analysis, what we do in system security engineering. That in that activity, we have description of what we do during stakeholder needs and requirements definition. And so what should be done in those boxes has already been codified and reviewed and updated and made a part of NIST 800-160. So we have a good place to start from. Appendix C is called Security Policy and Requirements. Security policies being the rules that you're going to use, basically many of the requirements that you're going to put on the people that are going to be interacting with the systems and with the people that are going to be designing the systems. And then we have requirements that we define as stakeholder security requirements and system security requirements. Again, there's a right source to be taking from for this project. And I didn't talk about this last month, but the idea of how can you add to your verification arsenal this concept of an assurance case. And this is something that's done in safety, and we're seeing it more and more in system security. The idea of a security assurance claim and what are your assurance needs and how would you use this to be able to verify your security requirements and validate your security needs. And then volume 2 is all about the cyber resiliency techniques. So those 2 volumes give us a source for this project. I also wanted to point out, we did some work in a joint project with the product line engineering working group, and we landed on this cyber resiliency wheel technique that was published in a special issue of the INCOSE Insight in September 2020. And the idea here was that during the architecture development, that's where we can do that cyber risk analysis, that security risk analysis. And so we were looking at how this wheel could be used in a general case, not something you do at the end, but the architecture team has completed a particular architecture artifact. That's where you stop and say, let's take that artifact around the wheel and see if we identify any gaps in our cybersecurity and cyber resiliency that we want to address. And so each artifact goes through the wheel. We identify the cyber effects, attacks, and concerns. That's all part of developing those threat scenarios, misuse cases, and loss scenarios. And then NIST 800-160 has a set of resiliency capabilities in volume 2. So we identify which ones are already there. We describe them as techniques in the architecture. And then we map the techniques to the concerns, and we identify where we have gaps. And then we identify enhancements to address those gaps. So those additional security capabilities become additional security requirements. This is the last slide in the package. The discussion we want to have now is, how do these needs, requirements, verification, and validation activities apply to system security engineering? How can we take from the left side the real world expectations in the system security language? We would define these as, what do we need the system to do no matter what's happening? How do we translate this integrated set of needs? What does that mean to a system security engineer? And then as we do the needs analysis, that's the lifecycle concepts and the needs definition, that will give us our integrated set of needs. Then we do our requirements definition. So that's what we need to define, that will develop this list of design input requirements, which are the system requirements that you are allocating to the architecture team and the design definition team. And then you transform the design input requirements, which are your system requirements, into design output specifications, which are your subsystem specifications. And then when you integrate these together, you get the realized system of interest. And we need to also take into account how it will be operated, maintained, and disposed. So that's the transformation of needs to requirements, to specifications for subsystems, to the realized system. And then on the bottom, you have the arrows that come back, where you are verifying the system against the subsystem specifications. You're verifying the system against the system requirements. And the validation is above the center line. We're going to validate the system against the needs, but we're also going to be validating the subsystem specifications against the needs, and we're going to be validating the system requirements against the needs to make sure that we've captured what is there. So how do we bridge between the requirements working group products, which are defining this graphic here, and how do we make this relevant to system security engineering practitioners?
Couple things. I think that the outside boxes are extremely important. Is once you've fielded the system and you're in operations, is the validation that what we have still meets the stakeholder real world expectations, because change happens, new threats come up. There's a lot of issues that come in. So we got to always be asking that question. Yeah, we tried to address system security during developing the system, but once we fielded the system and it's in regular operations, we still have to do post-development validation continuously. And also we got to do post-development verification. Is the system still meeting the requirements? For different reasons, different systems over the lifetime, they may no longer meet the requirements. The requirements are fine, but they may not meet those requirements. So we got to do the post-development verification validation as well. And I don't know how that's addressed. A lot of system engineers, they focus on delivering a system because from an acquisition standpoint, you deliver a system to the customer and then the rest of it's up to the customer. But the customer needs to make sure that they have some capability to do the post-development verification validation. The other point I want to make, does anyone have any comments on that?
Yeah, I do. This is Rick Duff. In the work that we did on security in the future of systems engineering, where we developed 11 concepts ready for maturation in practice, one of them very specifically dealt with the need to model why you should trust the system. In other words, modeling the trustworthiness of the system. It would seem to me that if in fact you did have models that showed why you should trust the system, that would be a valuable part of verification and validation.
What would those models look like?
I have no idea. I've never built one. Basically, the model's supposed to give you an ability to trace a need down to an implementation.
So the idea is that you model the system, you are able to use that model to explore what would happen as the threat evolves.
Absolutely.
And-
I mean, you're modeling the security in the system.
Right. We had this a session where we were looking at how could we have sustainable security. The idea here being that you're designing the system to be secure about the threat you now know, but how can we describe that loss scenario and how can we describe that threat scenario in a pattern that would represent how it is now, how it used to be, and how it might be in the future.
The concept here is to build a model of the security mechanisms, the functionality of the security that actually delivers against the need that has been stated, as opposed to not having that. And then you have nothing to do except to test the system and hope that you actually throw the right kinds of tests at it.
Right. Some of the threat scenarios, you don't really want to throw them against the real system that's out there, and have it not recover.
So when we have professional hackers that make it a career to break into a system, isn't that kind of a continuous validation activity in a way where you could actually hire your own friendly hackers where they're continually trying to see if they can get around your security safeguards?
That's what you talk about with the cyber range, where you're going to have a red team, blue team. You have a team that is going to try to protect the system and another team that's going to try to attack it. And yeah, they're white hats, they're ethical hackers.
We would want them to be involved at the beginning. One, identify the loss scenarios, but also what you need to do to protect against those, and then come up with a set of specific requirements that would drive the architecture and design of the system that you could verify against, and then you could go and validate against those loss scenarios.
Right. What you're describing is exactly the two anti-patterns that have happened when people recognize that they're a resource. One is this idea that we're going to send it to the cyber range and the white hats are going to find everything that's wrong with it and they'll give us a punch list and then we'll fix it. And then the other is the security review after the design, where you bring the people that typically work in the cyber range, that have the white hats, that have the knowledge of what threats are out there and what kind of mitigations are effective against those threats, but they come in for one review after the design is complete. So I think you're absolutely right. That kind of expertise needs to be brought in during the needs analysis, during the requirements analysis.
Yeah,
So we want those people asking the stakeholders what mission threats are critical and what loss can you tolerate. And that becomes your basis for the requirements.
So with that, this left side between stakeholder real world expectations and the integrated set of needs, this is an expansion of that. We have on the left all the activities that we do to gather the information we need, including the stakeholder real world expectations, all the use cases. In this case would be your loss scenarios, part of the elicitation with the different experts. So this is stuff that's done at higher levels. when you look at the different process areas for 15288, the business and mission analysis and stakeholder needs and requirements definition processes, they're going to result in all this information. But now at the system level, now that I've gathered that information, now I got to come up with some concepts, how I'm going to be able to deal with whatever it is. In this case, for system security, I would come out with the inputs, all your loss scenarios, all your driver's constraints, so the standards, regulations, everything that we have to deal with for system security. And then you come up with, as far as your lifecycle concepts across the lifecycle, how are we going to address all those system security issues that were identified? So we should have a process for doing that. So part of the guide could be this yellow box in the bottom, organizational requirements for defined lifecycle concepts. What guidance can you give a practitioner on how they're going to define the concepts for addressing the system security?
Isn't this governed by the NIST SP standards?
Who's speaking?
I'm sorry, this is Doug Crocker. And I'm
Yeah.
dealing with this right now with some weapon system stuff that we're working on now. So this is a very timely discussion for me. But I would say, isn't this governed by the NIST SP standards?
That was something that gives us some of that, right? If you look at this process that Lou's talking about, is that needs analysis, which you will find in the business or mission analysis piece, and also in the stakeholder part. So yes.
Yeah, but what I'm saying here is, I know for the Department of Defense, in all our new contracts, they call out the NIST SP, standard practitioners. And a lot of the times within the organizations, we'll have internal processes and stuff like that. And we're still kind of dated during information assurance. There was a big transfer over to NIST SP. That's commercial standards now, to where it's not just within the Department of Defense for classified networks and things like that. They've expanded those standards now to include commercial application well. So, saying organizational requirements for defining lifecycle concepts, I just got out of a meeting today. I presented a slide very similar to this. I'm really trying to push us over in the INCOSE. And I made the comment that we don't want to restrict our methodologies of how to do these things just based upon our institutional knowledge. We should be basing this upon commercial standards that are identified for this process. And this yellow block right here, I purposely modified it and said, this is what's in our contract. This is what we're supposed to meet. And I put in the NIST SP standards 800 series. And then there's other ones like -150 for T-1 threats and things of that sort that are really driven by the concept of developing an architectural framework instead of telling them specifically what you have to do. There is no system threat assessment report anymore, because that makes the assumption that you understand or you know all the types of threats. And the NIST SP was the transition away from information assurance over to a framework.
And what I'm recommending that we use the 800-160 as the basis, that's the one where a lot of people for a long time have said, okay, this is when we talk about business or mission analysis, we understand what that is. And then NIST 800-160 says, look, the security purpose is to define the security aspects.
Yes.
Related to the strategic problems. I have NIST 800-160 open in front of me. And to identify the security objectives, security concerns, and security concerns.
It works you through the framework. It tells you the process that you have to go through, the methodology on how to do it. And that's the only bone I had to pick with just saying organizational requirements for delivering lifecycle concepts. I'm coming into a new organization. I know this because I worked at INSCOM. I worked at I worked at those agencies, so I'm very familiar with those standards and what they was developed to do. And I'm just making the point that it would be helpful, because I got pushback in the organization I'm in right now, start talking about information assurance. And I'm like, that's dated. The NIST standard SP 800s, the SP 150, those are the current versions of how to make sure in our cybersecurity processes that we set up a framework to do this in.
Right. And I agree with you absolutely. And what happens is that the organizational requirements, I think NIST 800-160 is the standard, But depending on what your organization is, you may have additional standards. For example, if you are making biomedical devices, you have additional constraints from the FDA related to security.
You hit it right on the nose. And maybe the way to deal with that is we should have a section where it talks about organizational life cycle concepts and needs definition and gives those as examples.
Right.
So these yellow boxes aren't meant to be standards. Standards are requirements on what your organization's processes are going to be. And what these yellow boxes are is your organizational processes in response to the standards. What are the work instructions you want your people and your organization to follow that results in those standards being met?
Yeah, but the only comment that I have to that, and that is there's a difference between processes and methods. And the NIST standards give you a method. And I, as a systems engineering manager, I always want to give not just the internal organizational process, but a method upon which to do it. And that's where that NIST standard comes in. It gives you a method on developing that framework, what type of questions to ask, the checklist, how you, elicit the requirements from the customer, fully understanding the bounds of the system, external, internal interfaces and all of that. The broad statements you have here, I get caught up in getting debates or whatnot, because they'll be talking about processes. And what I'm talking about is methods that are best practices out there. And the NIST SP are really best practices on how to do this,
Yeah, when I teach architecture, when I teach requirements development, any of the system engineering classes, I make a distinction between a method, a process, and a tool.
And a tool and environment. Yep. PMTE. Right. That changed our whole world back in '95. I have that white paper from AT&T in my inbox and I share it with the world. Right. PMTE. We're developing a system engineering methodology. And as the system engineering managers, our systems engineers, our job is to develop a tool to manage the creation or realization of system capabilities. So,
yeah. So Lou, I think the key point you made there is that the organizational process is in response to the standards. And one of the things we need to make sure is those standards reflect 800-160 and not RMF, not 800-53. Yeah. Because that's the concern, is that the organizational requirements for defining a needs and definition make of security as, non-functional requirements. And if that's the case, that's something we need to inform.
We need to make sure it's clearly stated. So a guy like me who gets it, I can say it's not Doug's idea. I can reference the document that's published by INCOSE or whatnot that makes that distinction,
So the idea of this cycle, right, the reason you have the design controls on the bottom is that as you're developing this integrated set of needs, which I think for system security is a set of security objectives and security concerns. It's not things that you need the system to do. It's security concerns that you need to make sure are addressed.
That you consider. You need to, as you're going through the process, you need to consider these things. Yeah.
Carlo has his hand raised.
I was wondering if it's to think of items looking to the reliability example. I see a lot of parallelisms. Obviously, there is not the reliability theory behind, and I understand that there are different rules, but there are also a lot of similarities in what is the weakest component or weakest gate and so on. So getting a bit back in the discussion, sorry for this, said what could be a model to validate or to verify better the security need that could be similar partly to the reliability approach, where you know what is the weakest point, what can be parallel, blah, 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 blah. Obviously, there is a theory that probably doesn't exist.
A vulnerability is not the weakest part of the system if that part of the system doesn't impact a critical mission scenario.
It's a threat vector, right? With a more appropriate, if this creates a threat vector, I think that's what the thing is. You don't want any threat vectors to where someone can possibly penetrate the system.
That's why I represented the cyber risk as the combination of the criticality analysis, the impact analysis, and the vulnerability analysis.
It's one thing if they have access to an unclassified network. It's a whole nother thing if they have a threat vector to where they can access your classified data.
Mhm.
So from a criticality analysis, there are two different levels.
Doug, you had mentioned an old paper that made some distinctions. Can you put
Yes.
that paper in the chat?
Sure can. I have it.
Thank
I
you.
have it right in my inbox. I'll share it with everybody.
Yes, I would like to see that. Thank you.
Yep.
Right, because one of the things we found is that if you only have process but no methods, then you have a lot of activities to do, but you don't really know why you're doing them. And that's part of what we get at with the controls, is that it gives you a process, but it doesn't give you a method making the system secure and resilient.
Well, I'll make a comment that I love to carry. One of my managers back when I was working for the Deputy Assistant Secretary of Defense. And that is that we never want to have our methods tied to our institutional competency. And by that, when the Requirements Working Group published a needs, requirements, verification, and validation lifecycle manual, that was a godsend for me because I had an authoritative reference to where I could go and show how our internal methods were based upon the institutional knowledge of the system engineers who had worked here for 20, 30 years. But now I had something I could reference that was outside, that was really based upon industry best practices. And I could compare and contrast that against how they were still doing things in accordance with MIL Standard 498. And the world has shifted over to 15288. Requirements development, requirements management, requirements controls, all of those are processes. What's changed is the method on how you do it. So we just got 42010 that just came out on Monday. It changes for architectural descriptions. It changes the method. The process of developing architectures, functional architectures, logical architectures, stuff like that, the process doesn't change. The method of how you do it is what evolves.
Process is what to do, the method is how to do it, and the tool is what makes it easier.
There you go. And the environment then is the added part of it. So as we go to MBSE, making the distinction between those four, and that's what this white paper does. It was published back in '94. But if you look at any systems engineering manual or any system engineering book or whatnot, you see they reference this because it really created our profession. Because the methods are what's taught in college. You go get a system engineering degree, you learn these methods of how to do requirements development, stuff like that. So when you're hiring new people in, you want to bring in new methods of how to do stuff, current methods on how to do it. And then, oh, by the way, the people who are still doing it in an old way, you have an authoritative reference on maybe a better way to do it.
So what's the difference between a method and an activity?
It depends on the corporation. Like, for example, the company I work with now, they would talk about procedures. So it became, what's the difference between a method and a procedure? Procedures are step-by-step, meaning that you have to do this first, do that second, do that third, do that fourth, or whatnot. Yeah. A method, I can do allocation of my requirements today, and then tomorrow I can go do traceability. I can jump around. The methods can vary. You don't have to do them step by step to get the output. So that's kind of how I had a session today, working with a team. And I had that question because in our current internal processes, they refer to processes and then they refer to procedures. And this thing I was saying is, well, if you look at the INCOSE requirements writing guide, you look at the ISO standard 29148, it gives you methods on how to develop qualitative measures of a requirement. I can jump around and kind of do that all over the place concurrently. It's not step by step. I just had this session today with all my systems engineers to try to push this transition and then make sure we're doing things in accordance with our internal processes. We don't have to change the processes because a lot of times that's too hard to do. But we need to stay current on new methods. What we're doing right here is introducing a new conceptual depiction on how to do these things that in turn turns into a method on how to verify and validate. Like I said, I use that needs, requirements, verification and validation lifecycle manual daily. This is a very valuable godsend to me. It's allowed me to win over some converts by using these depictions for context and stuff like that, explaining the difference between verification and validation and the various different phases of development and things of that sort. So that's all I'm saying is I'm just kind of reverberating back some of the pushback that I got and making that clear distinction. And I'll post the actual article I'm talking about, the PMTE, which is a classic from AT&T from 1994. And I've shared it amongst the teams to where sometimes you get caught talking past each other. And we need to make sure we're clear also in our depictions in processes versus methods.
So you're familiar with the Requirements Working Group products. Are you part of the System Security Engineering Working Group as well?
No, I'm not. I'm the part of the DoD Working Group, which we don't have a lot of meetings there because I'm doing Department of Defense stuff right now with the Abrams tank and the Stryker vehicle, but I'm not a part of the system security. I do have a cybersecurity expert that I kind of use that I'd like to introduce. I'm really trying to push GD back to be much more involved in INCOSE. I'm kind of driving that internally within the company. And I would like to have my cybersecurity engineer actually participate a lot more and be a part of this piece. But I'd like to be a part of it.
I'd like to recruit them to be part of the project, because what I'm looking for is evidence that there's somebody else on the planet that has read the needs and requirements manual and NIST 800-160.
Okay, I'm one of them, so I'm not. But don't worry, my cybersecurity guy, he's got a copy of it as well. So
one thing that's in the needs and requirements manual is it takes you a little bit from 15288. They list processes, and then within the processes, they list a series of activities.
Yep.
And for each process, you got maybe 3 pages. And so about a half of that is describing the activities, and then there's an elaboration. But for a practitioner, what's not there is practical lessons learned, get your hands dirty and doing things. And so what the manual's doing, like in 15288, it says you need to identify external and internal stakeholders, and it says elicit stakeholder needs, but that's all it says. It stops there.
It's a process.
Now the manual goes into the actual activity of actually doing it and giving people guidance on things they should consider when doing those things. And so that's how it's set up. So we have a series of activities like this. And so from a system security standpoint, being we have this framework in the manual, then how would you tailor each of these activities specifically to focus on and give people guidance what they need to do from a system security engineering standpoint?
Let me give you an example, Lou. You've got section 431, which is define the problem, threat, or opportunity. And in NIST 800-160, it talks about BA 2.1, that's analyze the problems or opportunities in the context of security relevant trade space factors. And it has a note on that. I'm not sure that I want, when you say tailoring a needs and requirements manual, I think that's NIST 800-160 has already done that. What I'm trying to do is find a way to make the two relevant, so that if somebody's familiar with NIST 800-160, they can then look at the needs and requirements manual and see themselves. And that's something in the 4 minutes we have left, maybe talk about what is the goal of this product, because I don't want to have it be.
Well, let's link up with them. I worked for the Deputy Assistant Secretary of Defense and spent a lot of time over there at NIST. I really think that we should link up with them. Because what's happening is, especially in DoD contracts and even commercial contracts, those standards are being listed in the contracts as far as guidelines for you and your security. And I've sat down with those guys in a room together, and really and truthfully, it'd be wonderful, I think, for our methodologies to reference their standards, because then it brings reality. I get a contract for the Abrams program, and in that contract, it has a procedural and gives me this set of requirements for the NIST SP Special Publications 800 series. It'll list specifically that in there. And now in the system security portion of the needs and requirements document, gives me reality. I understand now that those methods are guidelines that I've been given from the National Institute of Standards and Technology for cybersecurity, and it links the two together.
What I'm envisioning, so what I think would be a useful guide is what I refer to as the decoder ring, the Rosetta Stone. How do you reconcile those two? So that when
and a lot of it would be just using the same
verbiage.
verbiage. Think about that. Even if we just got together and made sure we use the same verbiage, that would help.
Yep.
So like you said, if you look at the SP, if you really know what you're looking for and you recognize that concept between the difference between a process and a method, you can see this is a method. So when we have that little yellow box down there that talk about organizational methodologies and stuff like that, that really shouldn't come from the organization, because the organization is limited based upon the competency within the organization. But if we cross-reference that to the NIST standards, then it's industry best practices, and you're not limited to just what we know internally.
Well, and I think what happens when we talk about security, and it may not be the case for other aspects that would have a perspective on the requirements working group products, is that the security engineers have been, pulling their hair out trying to get the organization to recognize NIST standard or some other standard, and that you can't just plod along and go comma securely. And so one of the things that I would want to bring out in the guide is that box in the needs and requirements manual. You don't just go to it blindly. You look at those organizational processes and say, do these implement the standards that make sense?
Yep.
If not, that's a different championing project you need to take on.
And you get away from the concept of I just need a tool, and the tool is going to do all this. I'm going to run NASU scans and stuff like that, and that's going to provide me with my security.
Oh,
you know, and not knowing that something as innocent as a thumb drive can create a threat vector. You know, there's a reason why you can't go into a SCIF with a cell phone or a thumb drive, because I learned this when I was working at Intel on the Z9D processor. A person can insert a thumb drive into a computer and during boot up, install malware on the firmware to where all of your virus software, malware, and stuff like that, it hasn't even been started up yet, so we can't even detect it. So once that thread is installed on the firmware, all of that stuff has been reduced to nothing.
Right.
So, but we didn't learn that until after. You know, I think the most famous one was the theft of the DNC emails. That's how they did it, and it was not until we learned that now the NIST standard, 800-150. That deals with T-1 threats, meaning threat vectors that can probably be introduced into your system before boot up. T-1, before the boot up and before your virus software protection, malware protection, all that type stuff is stood up. These are T-1 threats that can be introduced in the BIOS or can be introduced into the firmware to where none of those tools will even detect.
I'm going to have to drop off pretty soon. So what I wanted to do was ask the people who haven't spoke up, do we have any volunteers to help us with this project? This is a kickoff for this project, and basically saying this is what we're trying to do and take on next steps, hoping that we can get some traction on this at the IW to be able to get people working on this Rosetta Stone.
Yes, I've thrown my name into the ring, so I will definitely like to be a part of this. It's something I'm working on now. I've got a lot of past experience, nightmares, you know, for how important this is.
So Beth, given that you have this one document that goes into a lot of the detail, what is your vision value add that this new guide would provide practitioners?
To be a translation, to be able to say, if you're familiar with the needs and requirements manual and you want to apply it to system security, here's how it translates. That's exactly the same thing I'm doing with the System of Systems guide, because System of Systems has its own standard. It's not NIST, it's a ISO standard. What are the System of Systems perspectives on 15288?
I think the results of this project works in the other direction as well. Some people may pick up this guide without having yet read the needs and requirements document because of their interest in security, and then go read the needs and requirements when they see some value demonstrated.
As a result of it, yes.
Absolutely. And why I call it a Rosetta Stone is what it was helpful for me when I was reading the needs and requirements manual the first time was I was looking at it to see, does this break when I think about security? Does this break when I think about System of Systems? And I convinced myself it didn't. But I convinced myself it didn't because in my head, I was making these translations. And so what I don't want is for a system security expert or a system security engineering SME to pick up the needs and requirements manual and say, oh, this doesn't apply to me. I want to be able to have a document that says, here's how it applies to you. When you're thinking about requirements analysis and there's something there about use cases, you need to think about loss scenarios. When you talk about critical assets, where is it in the needs and requirements manual? When you talk about threat scenarios, where is it in the needs and requirements manual? And I think that Rosetta Stone is what's going to be a useful product.
Yep. But I do recommend that we link up with the NIST publishers and use the same verbiage. You know, similar verbiage in that Rosetta Stone. I think that's key.
We had one of the NIST authors on the call the last month, so I think we're on our way to doing that.
Okay, it seems like we are out of time. I want to thank everyone for attending. With that, I'm going to stop recording